Hey everyone, and welcome back. We're diving deep into AI and language models today.
Right.
Like those crazy smart computer programs that can write stories or translate languages and even answer your questions.
Oh, yeah. It's such a fast-moving field. I'm
Yeah.
really impressed by how quickly things are changing.
For real. And so today's deep dive is all about this new paper. And it focuses on a really cool concept called test time scaling. It's kind of like you're giving your AI this boost in thinking power,
Yeah,
but you do it during a test. So you don't have to retrain it from scratch, because that can take like forever and cost a ton.
totally. The paper's called Simple Test Time Scaling, and the researchers are all about finding easier and faster ways to make these powerful models even smarter.
So it's like they found a shortcut to get super intelligence. That sounds pretty awesome.
It does, but the real problem they wanted to solve was figuring out how to improve how well these language models can actually reason. Like working through complex problems, they don't just want the AI to spit out canned responses. They want it to think more like us.
Gotcha. So they want the AI to think critically and solve problems, like a digital Sherlock Holmes.
Exactly. And to do that, they actually built a new data set called S1K. It's this collection of like 1,000 super challenging questions that need step-by-step reasoning. It's like they're giving the AI a mental workout with a super smart tutor.
Whoa, 1,000 tough questions. But do they have to train the AI on like all of those questions to get good results?
That's what's so cool. They found that their AI, which is called S132B, could actually get really good at problem solving with just a small chunk of that data. Like only 1,000 practice questions from the data set were enough for them to see big improvements in the AI's reasoning skills.
Wait a second, only 1,000. It's so much less training than I thought.
It is super efficient, isn't it? It kind of shows that the quality and how the training data is structured are just as important as how much data there is. It's like giving a student the right practice problems instead of just burying them in busy work.
So they figured out how to make the AI a fast learner. That's really impressive. So now I'm kind of curious about this budget forcing thing they mentioned in the paper.
Yeah.
What exactly is that? And how does it actually help the AI think better?
So budget forcing is this clever way to make the AI spend more time thinking about a problem, really work on it. Imagine you're watching a detective movie, and the detective's totally stumped on this case. Budget forcing is like giving the detective extra time to look at the clues and try different things out to put the puzzle pieces together.
Oh, I see. It's like saying, hold on there, Sherlock. Don't jump to any conclusions yet. Take your time, use your brain, and see if you can come up with an even better solution.
You got it. And the crazy part is, it works. The researchers found that giving the AI more thinking time actually led to more accurate answers and more well-thought-out solutions. It's like those times when you're struggling with a hard problem yourself, and then suddenly after thinking about it for a while, you have that aha moment.
Uh-huh. I've definitely had those aha moments, usually after staring at a problem for way too long. But tell me, is there just one way that an AI can think about a problem? Or are there different approaches?
That's a great question. Turns out AI can approach these problems in a couple of different ways: sequential thinking and parallel thinking.
Okay, I'm listening. What's the difference between those two?
Think about how you solve a puzzle. Do you carefully try each piece one by one? Following a step-by-step process, like a recipe, that's sequential thinking? Or do you kind of look at the whole puzzle in your head and brainstorm a bunch of different ideas all at once, like a team working on a project together? That's parallel thinking.
I'm definitely more of a step-by-step sequential thinker myself. I feel like I need clear instructions to guide me. But this AI Sherlock can do both, right?
Exactly. The AI can do both sequential and parallel processing. Depending on how hard the problem is, it can switch between these modes and pick the best way to think for that situation. It's like having this toolkit of different thinking styles.
Wow, this is fascinating. So it's not just about making the AI smarter, it's also about giving it different ways to think and approach a problem.
Absolutely. And that's where some of the really groundbreaking findings from this paper come in.
Okay, I'm hooked. Tell me everything. What are some of those aha moments that the researchers found? What really surprised them?
Well, one of the most interesting things they found was just how important the quality and diversity of the training data was. Those 1,000 challenging questions. Turns out they were like the key to unlocking the AI's reasoning skills.
So it's not just about giving the AI any random data. It's about giving it the right kind of mental workout, right? Like you wouldn't give a chess grandmaster a bunch of beginner puzzles to practice with.
Exactly. The AI needs those tough problems to really flex its mental muscles, to develop those sophisticated reasoning strategies. It's all about pushing the AI to its limits. and helping it grow.
I see what you mean. But even with all these cool techniques, test time scaling can't be a magic solution, right? There've got to be some limitations.
You're right. Think of it like this. You have this amazing classic sports car, a real beauty, and you can tune the engine and upgrade all the parts, but at some point you're going to hit the limit of what that car can actually do, based on how it was designed.
So there's like a feeling on how much smarter you can make the AI with this approach.
Exactly. But the researchers didn't stop there. They were curious about what would happen with problems that were so huge they wouldn't even fit into the AI's memory all at once.
Wait a minute. The AI has a memory limit. I thought these things were supposed to have like infinite storage for information.
They are powerful, but even AI has its limits. This memory limit is called the context window. It's basically how much information the AI can actually keep in mind at one time.
So it's kind of like working memory for humans. We can only juggle so many thoughts before things get all jumbled up.
That's a great way to think about it. And so to get around this problem, the researchers started experimenting with those parallel processing methods we talked about earlier. It's kind of like having a team of AI specialists, and each one focuses on a different part of this big complex problem, and then they put all their knowledge together.
Oh, so it's like putting together an AI dream team, each member bringing their own unique skills and ideas to the table. That's cool.
Exactly. And the best part, these AIs can actually communicate and share information while they're working. It's like this big collaborative effort, a hive mind working towards a common goal.
This is starting to sound like something out of a sci-fi movie. All these super intelligent AIs working together to solve problems that would make our brains explode.
It is pretty mind-blowing, and it opens up some really exciting possibilities for dealing with those huge challenges that have stumped humanity for centuries.
That's awesome. Speaking of mind-blowing, what other cool discoveries did the researchers make? I'm ready for some more of those aha moments.
One of the findings that really surprised me was the idea of inverse scaling with rejection sampling. It sounds counterintuitive, but it really highlights how complex and unpredictable these AI systems can be.
Inverse scaling.
Yeah.
That sounds like the opposite of what we want. And remind me what rejection sampling is again. It's been a while since my stats class.
It's like trying to find a rare gem hidden in a giant pile of rocks. You keep picking up rocks and looking at them and throwing them away until you finally find that one perfect gem. So with AI, it's like the AI generates a bunch of different solutions to a problem, and then it picks the best one based on certain rules.
Right. So you're basically filtering out all the bad solutions until you get to the winner.
Got it. But what's this inverse scaling all about? Why would having more options be a bad thing?
That's what's so surprising. The researchers found that sometimes giving the AI more tries or a bigger pile of rocks to look through actually made the results worse. It's like having too many choices can lead to analysis paralysis, You just freeze up. That's so interesting. I totally get that feeling of being overwhelmed when you have too many options. You start second-guessing yourself and overthinking everything.
Yeah.
And end up making a worse decision.
Exactly. It seems that even with all its power, AI can sometimes fall into the same traps we do. It shows that even though these systems are incredibly advanced, they're still under development, and we're constantly learning new things about how they work.
Yeah, it's a good reminder that AI research is all about exploration, full of surprises and unexpected twists and turns. Speaking of which, did the researchers figure out any ways to get around this whole inverse scaling problem?
They did. One approach they tried was to combine sequential and parallel processing methods in a clever way. It's like the AI is learning to become a master multitasker, switching back and forth between focused step-by-step thinking and broader brainstorming, depending on the task.
So it's kind of like having a team of experts working together. You've got your specialists who are really good at diving deep into specific things, and then you've got your generalists who can see the bigger picture and connect all the dots.
Exactly. And it seems like this hybrid approach is especially good for solving those really complex problems that need both deep analysis and creative problem-solving skills.
Like they're giving the AI this whole arsenal of cognitive tools to work with. I love it. Now I'm really curious about how all of this research can be applied to the real world. How could these techniques be used to solve problems that actually affect our lives?
Oh, man. The possibilities are just endless. Imagine AI helping scientists make these groundbreaking discoveries, like developing life-saving medicines or figuring out the secrets of the universe.
That would be amazing. It's like having a whole bunch of digital Einsteins working 24/7 to solve the biggest problems we face.
Right. And it goes way beyond science, too. Think about healthcare. AI could help doctors diagnose diseases earlier and way more accurately. And they could even personalize treatment plans and speed up how fast we can develop new therapies.
Whoa, that would be a total game changer for so many people. It's like having this super smart medical advisor right there with you, helping you make the best choices for your health.
Exactly. And don't forget about stuff like engineering and design AI could help us create energy systems that are more efficient and sustainable, or design cities that are smarter, and even build robots that can help us with everyday stuff.
Wow, the possibilities really are endless. It feels like we're right on the edge of this huge technological revolution, and it's all powered by AI. But with all this talk about super intelligent AI, it's hard not to think about the downsides, too. What about the ethical stuff? Could AI become too powerful, too independent?
Those are really important questions. And it's crucial that we have these open and honest conversations about how to develop and use AI responsibly. We need to make sure that AI is used for good, that it benefits all of humanity, and that we stay in control of these powerful technologies.
I totally agree. It's like we're creating a whole new species of intelligent beings. And it's our job to guide them and make sure they're aligned with our values.
Absolutely. It's a responsibility we all share. And it's going to take collaboration between researchers, policymakers, industry leaders, and everyday people. We need to work together to create a future where AI helps us and makes our lives better, but also respects our values and keeps us safe.
Well said. This deep dive has been an incredible journey. We've learned so much about how researchers are pushing the boundaries of what AI can do, exploring all these new techniques to make these models smarter, more efficient, more versatile.
And this is just the beginning. As these AI systems keep evolving and learning, who knows what amazing things they'll be able to do.
It's pretty exciting and kind of scary at the same time, don't you think?
It is, but that's what makes scientific progress so cool. It's all about pushing the limits, exploring the unknown, and taking on the challenges and opportunities that come with it.
I'm going to go out on a limb here and make a bold prediction. I think in the next 10 years, we're going to see AI systems that can reason and solve problems just as well as humans. Maybe even better.
I wouldn't doubt it for a second. The speed of innovation in AI is just mind-blowing. And who knows, maybe someday these AI systems will help us solve some of the biggest problems humanity is facing. That's a future I'm definitely excited to see.
Me too. Thanks for joining us on this deep dive into the world of AI. Until next time, keep exploring, keep questioning, keep those brains working.